Welcome back to the Physics Sports Network. I'm Jack Duffin.
I'm Ronan Schaefer.
And I'm Sawyer Ikeda.
To start off today's broadcast, we're going to the bowling alley. This beautiful lane measures to be 60 feet, or about 18.3 meters, long. Using the Olympic standard 7.25 kilogram ball, we see our bowlers hucking these bad boys at those unsuspecting pins. Reaching them in an average time of 2.05 seconds, we clock these balls flying at an astounding 8.9 meters per second, almost 20 miles per hour.
That form. When these bowlers line up for their throw, they raise their arm about a meter. By multiplying that distance by the ball mass and gravity, we find that the ball has potential energy over 71 joules. When the ball is released, this potential energy is converted to kinetic energy with some loss due to friction in the form of heat.
To get a strike, all 10 pins must be knocked over. Due to Newton's first law, objects at rest, in this case the pins, want to stay at rest, while objects in motion, such as the bowling ball, want to stay in motion. The resistance to change of an object is known as its inertia. As the bowling ball contacts the pins, it resists change in motion, causing it to knock the pin. However, to completely topple a pin, its center of gravity must fall outside its base. These pins are designed to have a low center of gravity with an exaggerated base to give our bowlers a real challenge. Looks like it's not holding them back too much.
Wowee! Look at that strike! Now, let's move on to our second event, the totally exciting game of golf. As you can see by our professional golf champion, Jack the Ripper Duffin, a lot goes into a perfect golf swing. When one hits the ball, it flies upward with a given velocity, with gravity bringing it back down to the course. The curve it follows is known as a parabola.
Newton's second law, stating that the acceleration of an object is directly proportional to the magnitude of the net force and inversely proportional to its mass, can be used to find the force that the golf ball comes down with. In simple terms, force equals mass times acceleration, or even simpler, F equals ma. Substituting the golf ball's mass of 0.045 kilograms and gravity at 9.8 meters per second squared, we find that it falls with a force of 0.441 newtons.
For our third and final event of the broadcast, we have the duel. In swordplay, players must try to knock their opponents off of the platform. Wielding swords, they hit each other to try to push each other onto the water below. This fight exhibits Newton's third law.
Indeed it does, Sawyer. Indeed it does. Newton's third law deals with actions and reactions. It states that for every action, there is an equal and opposite reaction. In this game, we see our sword fighter apply a force on his sword, which in turn applies a force on the opponent's sword. When the opponent is blocking, they compensate for that force, applying it back in order to hold their ground. However, if the opponent isn't blocking and they're hit, they fly back. After being hit enough, the opponent will be forced backwards off the platform, resulting in a loss for them. Bet you didn't notice Newton's second law there as well. As the opponent falls off the platform, gravity accelerates them towards the ground. When we multiply gravity by the person's mass, we can find the force he falls onto the water with.
Well, that's all the time we have for today's broadcast, folks. Thanks for tuning in, and we'll see you next time on Physics Sports Network.
Booty calling Jess.
You suck.
That's what you're doing.
That's not what I'm doing.
Then what are you doing?
Texting my mom. God damn. Thinking about like. Oh yeah! Oh, Oh Jack, you got a good grip on that ball. I'd like to see how you can handle it too.
Is that what you're laughing?
Strikes on the streets.
No, shut up. Shut up.
See that guy? That one right there? He's a loser.
Teach me. I'm doing better than last time.
What? What are you doing? Oh my god. Get it! Get out! Get it!
Suck it! Suck it! Yeah! Yeah!
Oh yes. For the win. Let's go.